to 19. We've got the position of particle is given along the y-axis by 2 centimeters times the sine of pi t over 4, where t is in seconds and y is in centimeters. First question, what's the average velocity of the particle between 0 and 2 seconds? Before we answer that one, a quick reminder, average velocity is just the change in position over the change in time. Technically, I should have written this as delta y in this case, but it's okay. And one last thing before we do this, I'm just going to rewrite this. The 2 centimeters, I'm going to write in terms of meters right away, so our answer ends up being in meters per second. And so in this case, all we have to do is plug in 2 seconds here and 0 seconds here. And if you notice again, what we end up over here is this simply becomes pi over 2. Sine of pi over 2 is 90. Sine of pi over 2 is 1. And so we simply end up with 0.02 minus 0 over 2, meaning our average velocity during this interval, 0.01 meters per second. B asks, what's the instantaneous velocity? Well, instantaneous velocity, we need the slope of the graph at that instant. To do that, we'll take the derivative of the y position. So I'm going to call this v sub y because it's the velocity in the y direction. Remember, we just take the pi over 4 out of the interior there, move it in front. So the pi ends up there. 0.02 divided by 4 is 0.005. And now we can actually solve this. So the instantaneous velocity at 0 seconds, we just plug in 0. Cosine of 0, of course, is 1. And so it simply ends up being 0.005 pi, or you can write it as that many meters per second. Same thing at 1 second, we plug in 1, and you end up with that. And then at 2 seconds, this becomes cosine of pi over 2, which of course is 0. Please note here that during this interval, our average velocity isn't any of these numbers. And you might say, oh, the average velocity should be this middle number. It's close, but not quite. And it's definitely not the average of the starting and end point. So it is interesting. The average is really quite a bit different than the instantaneous velocity anywhere along the point. Part C, what's the average acceleration between 0 and 2 seconds? Well, again, remember, average is just the change in the velocity over the change in time. In this case, we can use the two answers we have already, the velocity at 2 seconds minus the velocity at 0 seconds, which just ends up being this, or dividing that, you end up with that. Average acceleration between 0 and 2 seconds is given by that. And then D, what's the instantaneous acceleration? Well, again, I've got to do a derivative. If you do the derivative, in this case, again, dividing by 4, another pi comes out front. Negative sign, because the derivative of cosine is negative sign, gives us this expression. And then we just have to plug in our numbers. At 0, sine of 0 just simply is 0. At 1 second, you get this. And at 2 seconds, you get this. Again, please notice that none of these numbers match our average, nor could you take the average of the beginning and end, nor is it the middle number. This is a nice curve, and you can sort of see the difference here. I guess I probably should actually show it. For our negative sign graph, you end up with the slope here, the slope here, and the slope here are not the same as the average, which is the slope of this line here that connects these 2 points. Hopefully that helps. Have a good night. Talk to you soon.